Uh, Good afternoon, learners, and welcome back to Dr. D.R.Patil Vidyapeeth Center for Online Learning. I am your faculty for this course, that is OMB AIML 303 and OMBBA 305, that is Performing Analytics with Python. I think somebody is not on mute. Please mute yourself. So learners, in this session, we are going to learn about unit number 9 and unit number 10 and unit number 11. So today I'm going to complete the syllabus for this OMB AIML 303, as I have already extended these sessions more than the allocated number of sessions. So today I will try to complete all these three units of this subject, that is performing analytics with Python. So we'll start with unit number 9, that is analytics part 2. So before I could proceed, please confirm in the chat box that I'm audible and my screen is visible to all of you guys. Please confirm in the chat box. Yeah. Thank you, Kelvin. Thank you, Manju. So learners, in this session, we are going to learn about predictive analysis, logistic regression, decision trees, and support vector machine. But here, it is not possible to cover all these aspects, that is predictive analytics, logistic regression, decision trees, and support vector machines, all the examples. It's not possible in a single session. So here, what I will do, I will execute the example based on predictive analytics. Okay. So at the end of this unit, you will be able to understand various predictive analytics techniques and understand logistic regression, decision trees, and support vector machine. So basically here I'm focusing on predictive analytics. So a predictive analytics is the process of using historical data, statistical models, and machine learning algorithms to make the predictions about the future outcome or about the future events, which helps the organization to gain the insights, make informed decisions, and take the proactive action. So that is the main benefit of predictive analytics. That the predictive analytics is basically uses the historical data, and it uses some statistical models and machine learning algorithms to make the predictions about the future outcomes or the events. And that will ultimately help the organization in making informed decisions, getting the insights from the data, and take the appropriate or proactive actions. So this is the process of predictive analytics. This PPT is also available on Swayam. Please visit this Swayam and download this PPT and just go through the content. The content is self-explanatory, so I will not waste my time on explaining all these concepts theoretically. Straight away, I will move on to the practical aspect of this predictive analytics. So how we can perform a predictive analytics using Python in Google Colab. So here I will use the example of a customer, whether a customer will churn or not. Means what? Whether a customer will stop using the product or not. So here I want to predict the customer's churning, whether the customer will stop using the product or whether the customer will use the product. So here I'm making the predictions. So this is the entire process of predictive analytics, how it works. If it starts with problem definition, then data collection and preparation. Then we go for EDA, that is exploratory data analysis. Then we perform feature engineering, that we create new features, or we can transform the existing features to enhance the predictive power of the data that we have seen in the last sessions, in the last examples that I have explained. Or then The next step is model selection. We select the appropriate predictive model based on the problem type. Say, for example, it could be a regression model, it could be a classification model, or it could be a time series model, and the characteristics of the data. So here we select the model. After that, we split the data into training and testing data. And after that, the model that we have selected, we train the model on the training data. So once the model has been trained on training data, then we provide the testing data to the model so that the model can make predictions. And after that, we compare the results of testing and training. Then we will be able to interpret how well my model has learned. So this is the entire process. So these are the different techniques which can be used in predictive analytics, or we can say that these are the predictive modeling techniques, that is regression. Regression is basically used for continuous numerical values. Means what? If you want to, if your target variable is in a continuous variable or continuous number. See, for example, if you want to predict the stock prices, if you want to predict the selling price of a house, so uh, for such application, we can use the regression predictive modeling technique, where the target variable is in a continuous numerical variable, like for predicting the house selling price or for predicting the stock price. So for all these applications, we can use the regression predictive analytics model. And classification model is used for predicting the categorical outcome or assigning the data points to predefined classes. So for example, whether email is spam or not a spam. For such application, we can use the classification model. In the same way, whether a customer will churn out or not, again, for this kind of application, I can use the classification model. Again, the time series model can also be used for predicting the future events based on the patterns and the trends observed in the historical time-based series data. So this is the time series analysis, which is used for future predictions based on the patterns and the trends which are observed in historical time series data. So if your data is in a time series, then we go for the time series analysis model. And again, one more method is there that is called as ensemble method. The ensemble method combines multiple models. The ensemble method combines multiple models to improve the prediction accuracy or the overall performance of your model. So ensemble model combines multiple models. So for example, random forest. A random forest uses multiple decision trees. So in the example that I'm going to demonstrate, in that I have used the random forest classifier. And this random forest classifier belongs to a family of ensemble learning. And the ensemble refers to the use of multiple models. So ensemble method combines multiple models to improve the target variables accuracy. To improve the prediction accuracy and the robustness and improve the overall performance of your model. For example, bagging, it could be boosting, and stacking techniques are commonly employed in ensemble method. So these are some of the predictive modeling techniques that we can use for predicting a future event. So basically, a predictive analytics uses the historical data and some statistical methods and machine learning algorithms to make the predictions about the future events, such as whether a customer will churn out or not, whether a meal is a spam or not a spam, whether what would be the pricing of the house after 5 years, whether predictions about the sales, stock market. So all this can be all these events can be predicted with the help of predictive analytics. So I will directly go on to the example, and please confirm that my screen is visible to all of you guys. So here I am sharing the screen. Please give me a moment. Yeah. So I hope that my Google Colab page is visible to all of you in your system or on your system. That is unit9.ipynb. Is it visible, guys? Yeah. Thank you, Manju. So now, so this is the example. Here I am predicting whether a customer will churn out or not. Churning means what? Churn means a customer stops using a product, and not churn means a customer continue to use that product. So here I'm predicting whether a customer will churn out or not. So by using this example, I'm predicting customer uh, using that product continuously, or whether the customer will stop using a product or services or not. So as usual, first thing first, we import the necessary libraries, that is NumPy for numerical Python for performing numerical operations, and Pandas for working on the data frames. So Pandas are used for the numerical operations, and Pandas are used for the data manipulation and analysis. Then we have imported the train underscore test underscore split from scikit-learn to split the data set into training and testing set. Then we have imported as you can see in the example, we have imported the random forest classifier from the scikit-learn, which is an ensemble learning method for classification. So here I'm using the random forest classifier. It's a machine learning algorithm. Here I'm using for making the predictions, and this random forest classifier belongs to a family of ensemble learning. The ensemble learning, like I said, that combines multiple models. So here the random forest classifier uses multiple trees. So I'm using the random forest classifier, and again I am here importing the accuracy underscore score and classification underscore report and confusion matrix, that for evaluating the matrix for classification model. So this is about the importing of the libraries like NumPy for numerical operations, Pandas for data manipulation, and train underscore test underscore split for splitting the data into training and testing. Then random forest classifier for making predictions. Then accuracy score to evaluate the performance of my model, how well my model has learned. So for that, I'm using the metrics, that is accuracy. And again, I'm using the classification report and confusion matrix for evaluating my model's performance. After that, the second thing that you are noticing here, that here I have created I have generated a synthetic data set for demonstration purpose. So here I am generating the data set, that is a synthetic data set. As you can see here I have created a data set with the name, that is basically first I am creating a dictionary here. As you can see, data is equal to, in the curly braces, age as a key, income as a key, transaction as key, satisfaction as a key, online services as key, and churn as key as well. So this churn is what? The churn is the, we can say, the target. This is my target variable. Churn is my target variable. And in that churn, if I get a value as 1, it means that customer will churn. Means what? Customer will stop using the product. And if the value of this churn is 0, then I interpret as the customer continuously using that product, or customer will use that product. Means what? 1 for customer churning and 0 for customer not churning. So churn is my target variable. As you can say, churn is a predictor. Churn is a dependent variable, isn't it? And all other, that is age, income, that we can say as an independent variable. So here, first thing first, I have created a dictionary. After that, from that dictionary, I have created a data frame, as you can see here, with the object of pandas pd.data frame. In the bracket, I have provided the name of my dictionary, that is data, so that I can create a data frame from this dictionary. I hope you are getting it. So here I have created the data frame with the name DF. So in my DF, I've got age, income, transaction, satisfaction, online services, and churn. All these are the columns. And after that, here I have generated the random age, random income, random transactions, random satisfaction levels, random services, and random values for churning. So here I have generated the values, isn't it? And as you can see that this is a supervised learning algorithm. I'm using supervised. Why supervised? Because here I have the target variable. I have the independent variable and I have the target variable as well. I know what is my target is. So here I'm using the supervised learning algorithm. The supervised learning algorithm works on the labels, isn't it? So here I'm generating the values for churning as well, isn't it? So how I can do that? See that what I will do, I will divide the entire data set into training and testing. Say, for example, 75% for training and 25% for testing. So once I build the model by using the random forest classifier, I will train my model on that 75% of my data. Once that model has been trained on 75% of the data, now I will provide the remaining 25% of data, that is my training data, that is unseen data, to the model. And now I am asking the model to make the predictions the based on what you have learned in testing while you have tested the data. So now give me the prediction for the remaining 25% of the data, isn't it? So in this way, here I'm testing the accuracy level of my model, how well my model has predicted the churn, whether it will churn or not. For that, I have used the matrix, that is accuracy. So after that, I will compare two values, that is the output of testing and the output of training data. Then I will able to interpret on the basis of the output that how well my model has learned, how well my model has predicted for the unseen data, for the testing data, isn't it? So once the model has been trained on 70% of the data, then now I will provide the remaining 25% of the testing data, that is unseen data, to the model. Now I'm asking the model to make predictions based on these 25% of data, that is testing data, isn't it? So here, even for churn, I am generating the values randomly. But when I provide the testing data to the model, listen very carefully. When I'm providing the testing data to the model, from that testing data, I will delete the values for the churn. I will not provide the values for the churn feature. So you're getting my point. When I am training it, I am providing all the columns, that is age, income, transaction, satisfaction, online services, and churn as well when I am training it. Remember, when I'm training the model, I'm providing all the data, all the features, including age to churn when I'm training it. And that is 75% of the data that I'm giving for training my model. So once the model has been trained by using the random forest classifier, now I want to test how well the model has learned. And for that, what I will do, from that 25% of the testing data, I will remove all the values for the churn, all the values for the churn target variable. Now I'm asking my model to make predictions for that target variable, that is churn, that is 0 or 1. So once I got the result, once I got the predictions, now I will compare the results of both testing and training. And on the basis of that, I can interpret how well my model has learned. So this is the logic, or this is the interpretation of this example. I hope that you are understanding it. If you have any queries, please post your queries in the chat box. So here, first, I have created a dictionary, and from that dictionary, I have created a data frame. After that, as you can see here, I am splitting the data into features, that is X, and target variable Y. So now I'm splitting the data into features X, and my target variable is Y. So Y stands for churn, that is churn feature. So that's why, like I said, that when I provide the testing data, from that testing data, I will remove the churn target variable. I want my model to make predictions for the given data except the churn feature. So that's why here I'm splitting the data into feature X, that is from age to online services. So all those are being contained into the X feature variable, and the remaining single one, that is churn, will be contained into the target variable Y. So with the help of df.drop, I am dropping the churn from my x-axis. So now it means that for x is equal to df.drop. So here I'm dropping the value from the x-axis for the x features. So now x contains the features and y variable contains the target variable. So here x is equal to df.drop. I'm dropping the churn variable, that is target variable, for my x-axis, for my into x features. And now you can see that y is equal to df churn. So now y will contain only the target variable, that is churn. So now here y contains churn and x will contain all other features except the churn. So this is what the x will contain, and this is what the y will contain after executing this command, that is x is equal to df.drop and y is equal to df drop, oh, sorry, y is equal to df, in the bracket I'm specifying as churn. So it means that I have created a list with the only single target variable, that is churn, and that I can refer as Y. And here X will contain the all other features starting from age to online services, except the churn. Churn is been is been stored in the Y target variable, as you can see in the example. So after splitting the features into X and Y, the next thing is to split the data into testing and training data, isn't it? So here we have dropped the churn features. Okay, now with remaining data, that is X and Y, I need to split the data into testing and training, and that can be performed with the help of X underscore train, comma, X underscore test, comma, Y underscore train, comma, Y underscore test is equal to train underscore test underscore split. So this is the library that we have imported here. As you can see in example, here we have imported the train underscore test underscore split library from sklearn dot model underscore selection. So with using that, I'm splitting the data for X and Y. So for X and Y, test size is equal to 20%. So it means that I'm dividing the entire data set of 20% as testing and 80% for training. So this will divide the data into uh, 20% of 20% of training data, sorry, 20% of testing data and 80% of training data. So test size is equal to 20% and train size is equal to 80%. Means what? I should have more data for training. So that's why training data will have 80% and testing data will have 20%. So we need more data. If you have more data for testing, then it is better, it is suggested, it is ideal that if you have large amount of data for testing, sorry, for training, that is as good as it is considered. So we should have more data for training purpose, and even if you have less amount of data for testing, that will be okay. So that's why the proportion of the training and testing is 80% for training and 20% for testing. So this will split the data. After that, here I am using the random forest classifier. I am using the random forest classifier for as a model. So here I'm using the model to make the predictions, that is random forest model. A random forest model, a random forest classifier is created with 100 trees. So as you can see, trees equal to, that is 100, and it is trained on the training data. So you can see that here n estimator is equal to 100, means what? I am creating the random forest with 100 t's, and random underscore state is equal to 42, means what? Every time when you run this particular code, it will generate the same amount of trees, that is 100 trees. So here, after that, I am training my model by using the model.fit. So model.fit x comma train comma, sorry, model.fit x underscore train comma y underscore train. So here I am providing, as you can see, that a training data, that is x train and y train. So here I am training my model. First, I have created a model, that is random forest classifier. I have provided the estimator, that is 100 trees, and random state is equal to 42. After that, I am training my model with the help of model.fit. x underscore train, comma, y underscore train. This is my training data set that is of 80%. So once the model has been trained, the next uh, step is to provide the testing data to your model and ask your model to make the predictions. So here, with the help of model.predict, I am providing the x underscore test. So x underscore test will contain the testing data that is 20% of the data. So now here I'm asking my model to predict for the unseen data, for the testing data that is 20% of the data that I have splitted in the previous step. So model.predict argument is x underscore test. Now the model will make predictions for this x underscore testing data, and the results are stored in the predictions variable. After that, now I want to interpret these result. I want to interpret the value that has been uh, that has been returned by this model.predict function. So for that, here I'm using the matrix that is accuracy. I'm using the confusion matrix, and I'm using the classification underscore report. So here I'm using three matrix in order to evaluate the performance of my model, isn't it? So accuracy is equal to accuracy underscore score. Again, this is the library that we have imported. As you can see here, from sklearn.metrics, we have imported accuracy underscore score, comma, classifier underscore report, and confusion matrix as well. So these are the metrics I'm using for evaluating the performance of my model. So here, first thing first, that accuracy is equal to accuracy underscore score. I am providing, as you can see, the result of testing data and the result of my training data. So here you can see the predictions. The predictions will contain the result of test data, isn't it? And y underscore test will have the result of y underscore test, that is the result of training data. So as you can see here, when we have trained here, yeah, this is where we have trained, that is x underscore train and y underscore train. So after that, we have uh, trained the model here. Then we have provided uh, the testing data to make predictions on the testing data. So that is, now here I'm comparing the result of my testing data and training data with the help of accuracy underscore score. So this will give me the accuracy of how well my model has learned. I'm again using one more matrix, that is confusion matrix. Confusion conf underscore matrix is equal to confusion underscore matrix y underscore test, comma, prediction. So this will create a confusion matrix for my predictions data, for my the result of predictions and the result of testing. So on the basis of that, it will create a confusion matrix. Again, I'm creating a classification report for my data, that is y underscore test and predictions. So here, these are the metrics that I'm using, that is accuracy, confusion matrix, and classification report, in order to evaluate the performance of my model. So after that, I'm just printing the value of accuracy, the value of confusion matrix, and the value of the classification report. So here, I will execute this example one more time so that you can see the result here. So here I'm executing the example. This example will give me the accuracy that whether a customer will churn or will not churn, whether the customer will stop using that services or he will continue to use that product. So churn means 1, and that is whether the customer will stop using services. It is represented by the churning value as 1. And if you see a 0 value in churn as a target variable, then it means that this customer is continuously use the product, or he will use the product continuously. So now you can see that the accuracy of my model is 0.54, and you can see the confusion matrix and classification report. Now let's uh, try to understand, try to interpret the accuracy, which is 0.54. So what this signifies? This indicates that the model correctly predicted the outcome, that is churn or non-churn, for approximately 54% of the 54% of the instances in the data set. Means what? It has correctly predicted the target variable, that is churn or not churn, for approximately 54% of the 54% of the data in my data set. So we can say that this is a decent performance of my model. So my model has learned decently, that I can say, with the accuracy that I've got as 0.54, isn't it? So this is how we have to interpret. Now, if we talk about the confusion matrix, so I'm not giving more details about the confusion matrix here, but this value that you can see here as 51, 36, 56, and 57, what it means, how to interpret. So the confusion matrix provides a detailed breakdown of the model's predictions, how well the model has learned. So for example, true positives are 57. True positives are 57. True negatives are 51. So this is true positive and this is true negative. And this is false negative or false positive, that is 36, and false negatives are 56. So here, these are the values of my confusion matrix. Now let's go on to see the values of the classification report, that is precision, recall, F1 score, and support. So now we can have all these other metrics can be combined with the help of the classification report, where you can see the precision, where you can see the recall, where you can see the F1 score, where you can see the support as well. So here the precision for class 0. So this is class 0, non-churn is equal to 0.48. And precision for class 1, that is churn, is 61%. So we can say that the precision for the class 0, that is non-churn, which is below the average, below, that is 0.48. So it means that the model needs more enhancements. So for non-churning, the accuracy level is not acceptable. As you can see, for non-churning, that is represented by 0 as a class, that is 0.48, means what? 48%. So what it means that approximately for 48% of the data set, it has correctly given the value as non-churn, that is 48% only. So that is not ideal. But for the precision for class 1, that is churn, it's okay. That is 0.61, that is 61%. So it means that 61%, approximately 61% of my sample, of my data in the data set, it has correctly given the predictable variable, that is the target variable, that is churn. Means what? 68%, 61%, 61% people will churn. So here the precision for class 0, that is non-churn, is 48%, and the precision for class 1, that is churn, is 61%. So the precision is the ratio of correctly predicted the positive observations to the total predicted positives. And for instance, for class 0, this one, we have 48% of the predicted non-churn instances were true. non-churn. So this is not good for the class 0, that is non-churn. Now, if you talk about the recall, so what the recall is, the recall for class 0 is 59% and the recall for class 1 is 50%. So the recall is the ratio of correctly predicted positive observations to all the observations in the actual class. For class 0 is 59% of the actual non-churn instances were correctly predicted. So here we have used many metrics in order to evaluate the performance of our model, like accuracy that we have used. Then we have used the classification report. In that we have, it will give you many or the report of many matrices metrics, that is it will give you the many metrics for evaluating your system, such as precision, recall, F1 score, and support. So we have discussed about precision, recall. Now, what is F1 score? F1 score for class 0 is 53% and F1 score for class 1 is 55%, as you can see in the output. So F1 score, what is F1 score? F1 score is the weighted average of precision and recall. So it's a weighted average of precision and recall, that is F1 score. So it's a good metric for balancing the precision and recall, as it is the average of precision and recall. So it's a good metric for balancing the precision and recall, especially when there is an imbalance in the classes. Now, how we can able to interpret support? The number of actual instances of each class in the test data set. So the support will represent the number of actual instances, of each class in the data set. So as you can see, 87% belongs to class 0, 113 that is belongs to 1. So in this way, we can able to understand the values of support. Give me a moment. Yeah. So here we have interpreted all the values of all the metrics such as support, precision, F1 score, and the accuracy. So as a summary, we can say that the model shows a relatively balanced performance, but there is a room for improvement, and it correctly identify the churn, that is class 1, and non-churn as class 0 instances, but there are false positives and false negatives as well, as you have seen in the confusion matrix. The precision, recall, and F1 score metrics provides a more detailed view of the model's performance on each class. Depending on the specific goals and context, you might adjust the model or its threshold through to prioritize the precision or recall. And depending on the importance of false positive or false negatives in the application. So this is about the example of uh, predicting whether the customer will churn out or not. So here I have tried to explain the example, try to explain the predictive analytics with the help of example that here I have used the machine learning algorithm, that is random forest classifier. And here the random forest classifier can be used for classification as well as the regression model as well. And this random forest classifier belongs to a class of ensemble learning, where in ensemble learning, it uses multiple models. So as you can see here, in this classifier, we have used 100 trees or 100 decision trees. So here, this is the output. So we can say that my model has learned, has performed decently, 54 for the approximately 54% of the data set. But if you see the other metrics like the confusion metrics, like the F1 score, recall, and support, we can say that the model needs to be enhanced more. So with this, we come to the end of this unit number 9, that is predictive analytics. So now we move on to the next unit in this session, that is unit number 10, and that is social networking. And I hope that you people have understood this example, and I will share this Google Colab page to your email IDs. Like I have shared the all my Google pages, Google Colab pages that through the Google Drive. And again, also going to share the today's Google Colab page as well. So I hope that you people have understood this example clearly. If you have any queries, please put your queries in the chat box. So this is about unit number 9, that is predictive analytics, where I have explained first theoretically what is predictive analytics, what are the steps in that predictive analytics, and what are the methods, what are the models that can be used for predictive analytics. Then I have explained one example by using the random forest classifier in order to predict whether a customer churn or non-churn. So this is about the example. Now let's move on to the chapter number 10 in this OMB AIML 303 and OMBBA 305, that is performing analytics with Python. And this unit number 10 is all about social networking. So here in this chapter, I'm going to cover about benchmarking and data quality. So here I will demonstrate one example based on benchmarking. Okay. And again, there are subtopics like model design and documentation. These are all theoretical one. And again, you can see the example application, that is credit risk modeling, fraud detection, and recommender system. So here I will demonstrate the example of recommender system practically. So we'll start with first the theoretical knowledge of benchmarking, data quality, model design, and documentation. And at the end of this session, I will practically demonstrate one example, that is of recommender system, where I'm going to use the movie lens data set, which is available on Kaggle. So at the end of this unit, or what are the objectives of this unit? The objective is to understand the data quality, is to understand the definition and metrics of fraud detection, understand the methods used in credit risk modeling, understand the rules of model design and documentation, and benchmarking as well. So what is benchmarking? Benchmarking is basically a systematic process of comparing and evaluating performances or practices against the industry standards or best practices. It helps the organizations identify the areas for improvement, set performance goals, and achieve the higher levels of performance. So in this session, we try to explore the key features or concepts that are related in benchmarking. So what is benchmarking? Benchmarking is a systematic process of comparing and evaluating the performance of a model against the industry standards so that we can find out the areas for improvement, we can set the performance goals, and so that we can achieve the higher levels of performance. So here, what are the key concepts which are covered in benchmarking? That is the types of benchmarking like internal benchmarking, competitive benchmarking, functional benchmarking, and what are the steps that are carried out in benchmarking process. First is identifying the objectives. Second, select the benchmarking partners. Next, collect the data, then analyze and compare the data, then set the performance goals, develop the action plan, and monitor and review. So these are the general steps which are carried out in benchmarking process. Now we'll try to understand the data quality. So the in corporate information system, many databases are interconnected through real-time and batch data feeds. So in that case, so in the dynamism of these interconnected databases and the regular updates of the shared data have a significant impact on the data quality. So because of this interconnectivity, interconnected databases, it is very much important. It is very much important that we should give importance to the data quality. So because this interconnectivity of the data sets, they have a significant impact on overall data quality. So here, what would be the impact of poor data quality? What are the results of poor data quality? So here, as you can see, the it can reduce the customer satisfaction. It can increase the operating cost, that is the poor data quality. So the poor data quality can increase the operating system cost. It can decrease the customer satisfaction. It can decrease the employee job satisfaction, and it can impact the analytical decision-making process. And it is leading for the fitness for use concept. So the interconnection of database and regular data updates in corporate information system introduces the challenges to the data quality. And poor data quality negatively impacts customer satisfaction, increases operating system, reduces employee job satisfaction, and hampers the analytical decision-making process. And the concept of fitness for use, that is, that recognizes the relative existence of data, that is the relativity, that is the importance of the data quality, emphasizes that different decision context. So in the context of decision making, it have distinct data quality or not. It has whether data quality requirements are fulfilled or not. So understanding and addressing the data quality issues is crucial for organizations to ensure that they have the accurate and reliable data for their various purposes. So because of the connectivity of the databases, this interconnectivity has impacted the data quality. And if you have poor data quality, then it can lead to increase in the customer. It can lead to increase in operating cost. It can lead to decrease the customer satisfaction. It can reduce the employee job satisfaction. It can hamper the analytical decision, and as well as we need to understand the fitness for use concept, where we are ensuring the data that we have at our disposal fulfills all our requirement or not. So here, as an organization, we need to understand the quality of the data. We need to give enough attention to the data quality and address the data quality issues so that we can ensure that the organization is having accurate and reliable data for various purposes. So this is about the data quality. Now, model design and documentation. So the model design and documentation are essential steps in the development and implementation of models in various domains, such as in data science, machine learning, and software engineering as well. So here uh, we are going to highlight the key considerations in the process, that is model design and documentation. So first, model design. So what is model design? A model design refers to the process of creating a conceptual and technical blueprint of a model, which involves defining the model's objective, defining the inputs, defining the outputs, designing the algorithm, and implementation details. So here, when I say model designing is a process of creating a conceptual and technical blueprint of my proposed model, and that involves model's objectives, model's input, model's output, and building the algorithms and implementation details. So all these details are being defined in model design. So these are the key considerations in a model design, that is objectives and scope of your model, data, what are the data requirements, algorithm selection, which algorithm that you want to select. We need to take a decision on the model architecture, and we need to also take a decision on training and evaluation of the model as well. So these are the key considerations when you are going for designing a model. Now, we need to understand the model documentation. So as the model design is important, in the same way, model documentation is also as important as model designing. So model documentation is also crucial for maintaining the transparency, for maintaining the reproducibility and collaboration that allows the stakeholders to understand and validate the model. If you have a documentation, if you have well documented the model, so that will help the stakeholders to understand and validate the model, which will facilitate the knowledge sharing and ensures the future modifications and improvements. So from this point of view, from the point of view of future modifications, improvements, facilitating the knowledge sharing, convincing the stakeholders to understand, or to make the stakeholders to understand the model and to validate the model. From all these perspective, the model documentation is very, very important. And again, one important aspect of model documentation is that if you want to make any improvements or modification in future, the model documentation plays very, very important role, because it documents every detail of your model. So even if you want to make a small change, you need to go through the entire model documentation. Otherwise, a small change can impact the overall performance of your model. It can impact on overall output of your model. So before making any changes, we need to understand, we need to go through the model documentation. So once you understand the model, then you can make modifications or improvements in that model. So that's why model documentation is as important as model designing. What are the key component or key uh, areas, important areas of model documentation? That is overview and purpose, data description, model architecture, training process, evaluation result, assumptions and limitations, code and dependencies. So here, as you can see, that this model documentation will give you the detailed information about your model, about your system, starting with overview and purpose. and ending with the code and dependencies. So that's why model documentation is very, very important. Now, the examples or example applications, that is that one application can be the credit risk modeling, fraud detection, and recommender systems. So in this, we are going to understand these three examples, that is credit risk modeling, fraud detection, and recommender system as well. So here I'm going to I'm going to show you, demonstrate practically the recommender system, that is by using the movie lens data set. So where we can recommend the movies for a particular user. So first, that is credit risk modeling. In this modeling or in this application, the credit risk modeling involves assessing the credit worthiness of the individuals or the entities to identify to determine the likelihood of defaulting on their financial obligations or not. So it will help the financial institutes in making the informed lending decisions and managing the credit portfolios. So that is about credit risk modeling. Then the next could be the fraud detection. So the fraud detection involves identifying and preventing the fraudulent activities within various domains such as finance, insurance, e-commerce, and healthcare. So this will help to minimize the financial losses and maintain the integrity of business operations. So this is about the fraud detection. And the third one, that is recommender system. It's a system that will provide personalized recommendation for users based on their preferences and behaviors. They are widely used in e-commerce, content streaming platforms, social media, and other domains to enhance user experience and drive their engagement. So the techniques that we can use in this recommender system, that collaborative filtering, content-based filtering, hybrid approaches, evaluation metrics. So in my example, I'm going to use the collaborative filtering, user, that is user item interactions or user behavior data to identify the similar users or items and make the recommendations based on their patterns. So what is collaborative filtering? Collaborative filtering is a filtering where we identify the similar users or items and make the recommendations based on their patterns. So this is the techniques and considerations that we are going to use. So now let's move on to the example directly so that I can show you how we can able to use or how we can able to define or build the recommender system. So before I conclude this session, I have given the link for the feedback for this session. I hope this is visible to all of you. And I request the learners who are leaving this session, please fill this Google form and then leave this session if you want to leave. So here, I'm going to explain about this recommender system, or here I have built one recommender system. So first thing first, we need to mount the Google Drive. Since I have stored my movie lens data set into my Google Drive, so I need to mount it. So here I have mounted my Google Drive. After that, here I'm using the surprise library that is present in Skykit. Cola page is not showing. Okay, okay, give me a moment. Yeah. Is it visible now? Yeah. Thank you. So here I have to mount my Google Drive so that I can refer the movie lens data set. So after that, Here, as you can see in the cell, I have imported, first I have installed the scikit-surprise library. The scikit-surprise library is not automatically installed. We need to install it by using the pip command. So pip install scikit-surprise. I will explain why I have installed this library. So here we need to install it by using the pip command, because this surprise library will not be installed automatically. We need to install it explicitly by using the pip command, like pip install scikit-surprise. So this will install the scikit-surprise library. So once it has been successfully installed, then we'll move on to the next part of our code. So here I have imported the dataset class, the reader, and KNN basic from the surprise. So that's why here I have imported the surprise library. So here I have imported the necessary libraries from surprise.model_selection. I have imported the train_test_split for splitting the testing and training data. Again, I have imported the accuracy from surprise, and I have imported pandas. I imported the pandas as PD. So as you can see that it is successfully installed. After that, here I have imported the libraries which are required. I have imported this surprise library that is inbuilt, which is having a inbuilt. So this section imports the necessary libraries, and surprise is a Python library for building and analyzing the recommender system. So it has inbuilt methods, that is the surprise library. Like we can see that by it has the dataset dot load underscore built-in method by which I can load the dataset. In the previous example, we have used the read underscore CSV function, but here since I have imported the surprise library, and this surprise library has the inbuilt function that is called as load underscore built in. So this function will load the dataset, that is movie lens slash ML-100K dataset, and this dataset is available on Kaggle as well. So here, Surprise is a Python library which is used for building and analyzing the recommender system. So this is a simple example of recommender system for which I'm using the Surprise library for analyzing and building the recommender system. So first thing first, we need to load the movie lens dataset. As you can see, is equal to data is equal to dataset. Dataset is a class of Surprise library. So data is equal to dataset dot load underscore built in, and specify the name of the dataset. In this case is ML-100K, that is the dataset belongs to movie lens. So this will load the dataset into my Python code. So here the code loads the movie lens 100K dataset using the load underscore built-in method provided by the dataset class in the surprise library. So here I have explained every line by using the comment. As you can see that every code, every line has been explained by a comment below that. So the codes are simply self-explanatory. So after that, convert the surprise dataset to a pandas data frame so that I can view, because the structure of the surprise dataset is different from the pandas data frame. So if I say here data.info or data.describe will not work, because this surprise data set is having a different data structure. So just for the sake of displaying the records to the user, here I'm converted the surprise data set to a pandas data frame. Other than that, there is no use of this. particular code, this particular code. Just I want to call the function that is data.info so that I can view the records of my data set. So that's why I have converted the surprise data set to a pandas data frame with the following code, that is df is equal to pd. So that's why here I have imported the pandas library so that I can convert the surprise data set into a pandas data frame so that I can call the info and describe function on that data frame. That's the only thing. That is the only reason that I have written this code. Even if you have don't write this code, it will not impact. So here, just for the sake of viewing the data, I just converted the data, the surprise data frame to the pandas data frame. So by df is equal to pd dot data frame, I'm providing, as you can see here, data which contains a surprise data frame dot raw ratings, comma, column is equal to what columns it contains, that is user ID, item ID, ratings, and timestamp. So these are the features which are present in that movie lens data set, that is ML-100K. So here I'm providing the features of that data set, and from this I'm creating a pandas data frame with the name that is df. Now after that, I can display the basic information about my data frame by using the df.info and df.head as well, or also even you can call df.describe as well. So this will just print the basic information about your data set so that you can understand the characteristics of your data set, the content of your data set. So after that, I'm defining the similarity measures to be used. So here I'm using the user-based collaborative filtering. Like I said, that what is user-based collaborative filtering in the PPT that I have explained. So here I'm using the user-based collaborative filtering, like SIM underscore option is equal to name, that is key, cosine is a value, user based is a key, and a true is its value. So this code defines the similarity measures to be used in the collaborative filtering. And in this case, it uses the cosine similarity measures for the user-based collaborative filtering. So after that, I'm initializing the KNN basic model. So here I'm using the KNN basic model. So first thing first, I have created the object of KNN basic model by providing the SIM underscore options is equal to SIM underscore options. So here it initializes, this will initializes the KNN basic model for collaborative filtering and passing the defined similarity options. So what is similarity option? That is SIM underscore options is a similarity options. For that, I'm using the user-based collaborative filtering. So after that, I'm splitting the data into training and testing, as you can see here. So here my test size is 25%, and for training, I have created 75%. So test data contains 25% and training data contains 75%. So this code splits the data set into training and testing sets using the train underscore test underscore split method from the surprise. So it gives 75% of the data for training and 25% for testing. So after that, I need to train the model by using the model.fit and providing the train set, that is the training data set. So here I have trained my model. So this will train the model on the training set using the fit method. After that, once the model has been trained, now I am asking my model to make predictions on the testing data, like predictions is equal to model.test. I'm providing the test set so that now my model will make predictions for the test set, that is unseen data. So the model makes predictions on the test set using the test method. So after that, once you have the result of your predictions and the result of your training, now we will be able to compare the results, that is the predictions. So using the accuracy.rmsc, the code evaluates the model performance using the root mean squared error, that is RMSE. So it's a method which is used to evaluate the model's performance, that is RMSE stands for root mean squared error on the predictions. And here after that, once I have got the I have evaluated the model, now I want to print the results. I want to make the recommendations for the first five. I want to make the predictions for five recommendations for movies for a particular user. And for that, here I have defined a function called as get underscore top underscore n recommendations. So here I am getting the recommendations. After that, I'm sorting the recommendations. I'm sorting the predictions for each user and retrieve the top n. So the code defines the function called as get underscore top underscore n underscore recommendations to extract the top n recommendations for each user from the predictions. Now get the top five recommendations for a specified user. Say for example, user ID is equal to 196. So we can see that user ID I have given as 196. Now I want to get the five predictions for this particular user, that is user ID 196. So now I am asking the model to make the movie recommendation, the first five movie recommendations for the user 196. So that is top underscore n underscore recommendation is equal to get underscore top underscore n underscore recommendation, that is predictions, n is equal to 5, so that the function will get called and it will get the n recommendations for each user. After that, it will be sorted. Then I'm getting the result. After that, I'm printing the result for the top five recommendation for the user ID, that is 196, with the help of the print function. And finally, it prints and displays the top five recommendations for the specified user. So here I will execute this example so that you can see its result. See that even if the data set is not, if you are not installed, it is asking that whether you want to download the data set. Just type as say Y, so that the data set will get automatically installed in your Google Colab page. So you can see that the result. So this is the result of the info, that is df.info. And this is the result of the df.head. As you can see here, I have given the command to display the info and head. So here, this is info. Sorry, this is info and this is head. So after that, you can see the recommendations for the user, that is called as 196. So these are the recommendations. That is movie ID is 655. Movie ID is 382. Movie ID is 111. Movie ID is 381. Movie ID is 255. Based on the customer's behavior and based on the customer's data, that based on customer user ID, customer item, ratings, and timestamp. Here, I have recommended the first five movies for the customer ID is equal to 196. So this is an example of recommendation system. So with this, I will conclude the unit number 10. Now we'll move on to unit number 11, that is value addition. So I hope that the example is self-explanatory. Here I have given the explanation of each of these steps after the statement. So all these steps are explanatory. And again, I have given the explanation of each of these steps and output of each of these statements. I hope you have understood thoroughly. Now we'll move on to the next unit, that is the last unit of this OMBBA 305 and OMB AIML 303. And this topic is value addition. And this is the last topic of OMB AIML 303, that is performing analytics with Python. And the unit name is value addition. And in this topic, this is completely a theoretical one. I will just go through it. So in this topic, we are going to learn about introduction to machine learning and applications of machine learning. So at the end of this topic, that is topic number 11, you will be able to understand the basics of ML, the applications of ML, and understand the principles of ML. So basically, what is machine learning? Machine learning is a subfield of artificial intelligence. So machine learning is we can say a part of artificial intelligence that focuses on developing the algorithms and models that will enable the computers, that will enable your system, your application to learn and make predictions or decisions from the data without being explicitly programmed. And I would say that some of the concepts of machine learning that we have already used in our previous example, say for example, in predictions in the recommendation system, in the customer predictions, whether the customer will churn out or not, that is in a prediction analysis we have used. Again, in the last example that we have witnessed, that is in case of recommendation system also, we have used some concepts of machine learning. So basically, what is machine learning? Machine learning is a subfield of artificial intelligence which focuses on teaching the machine, teaching the models. And after that, once the model has been taught, we are giving some unseen data. Now make predictions. Now make the get the insights from that unseen data. So it uses it involves developing the algorithms, developing the models that will enable the computers to learn and make predictions or decisions from the data without being explicitly programmed. So that is the main concept of machine learning. So training data, like I have said, that the data that is used to train the ML model consisting of input features and corresponding target labels or outcomes as well. So in training data, we'll have all the features, including the target labels or outcomes as well. So in case of machine learning, we have three types of machine learning, that is supervised machine learning, unsupervised machine learning, and we can say the enforced machine learning. So here, basically, we are talking about the supervised learning, where the ML algorithm that learns from the labeled training data to make the predictions or classification on new or unseen data. So supervised learning is a type of machine learning algorithm that learns from the labeled data. So in case of supervised learning, we have the labeled data. In case of unsupervised learning, we don't have the labeled data. Here the machine learning will discover the patterns or the relationship in the unlabeled data without explicit target variables. So in case of supervised learning, machine learning, we have explicitly target variables, target labels. In case of unsupervised learning, we don't have explicit target labels. Here, the machine learning algorithms discovers the patterns and try to find out the relationship in the unlabeled data without explicit having the target labels. So this is two types of machine learning algorithm or machine learning types are there. That is supervised learning, unsupervised learning, and one more is there. Let just me give a moment. Yeah. So basically, we have three types of machine learning, that is supervised, unsupervised, and reinforcement learning. So there are three types of machine learning algorithm or machine learning types are there. That is supervised learning. unsupervised learning and uh, reinforcement learning. So in case of reinforcement learning, we train the model in an environment, and the model will learn by interacting with the agent. And for every interaction, the model will get a positive point or a negative point. If that uh, if that model makes a good move. So, for example, a chase, in a game of a chase, the agent will get a positive point for the right move and a negative point for a, incorrect move. So here, the machine learning algorithm, if you talk about the reinforcement machine learning, so here the agent interacts with that game and makes the move. So as the agent will accumulate the points, that is positive points and negative points, it will learn over a period of time that for which move I am getting a positive point and for which move I am getting a negative point. So over the period of time, as the model learns, as the model plays that game of chess over a period of time, after some time, the model will make maximum number of positive points. So in this way, we train the model by using the reinforcement learning, where the agent interacts with the environment, and uh, with the interaction with the environment, the agent will get positive points or negative points. And from that positive points and negative points, the model, the agent learns, will enhance its knowledge. So as the model enhances its knowledge, at after one point of time, it is expert in playing that particular game or making a move. Say, for example, driverless cars. Driverless cars are used, they used the reinforcement learning algorithm. So these are the key concepts in machine learning, that is training data that we use to train the ML model. Supervised learning, where we provide the training data to make predictions. So here in case of supervised learning, we have the labeled data, but in case of unsupervised learning, we don't have the labeled data. Means what? We don't have the target variables. So here in case of unsupervised learning, the algorithm will discover the patterns and the relationship which are present in the data set, and they will make the predictions. So for example, giving a set of patient history, medical history, what diseases that patient could develop in future, isn't it? So here we don't have a target variable. So for such application, we can use unsupervised learning. On the other hand, like we have seen in the example of customer churning or not. So that is the example of supervised learning, because we have the target variable, because we have the churn, either 1 or 0, isn't it? We train the data on training data and we test it afterwards. So when we test it, we simply remove that target variable and we are asking the model to make predictions on the unseen data. So in case of supervised learning, we train our model on labeled data. And in case of unsupervised learning, we don't have the labeled data. And in case of reinforcement learning, here the agent, your model, will interact with the environment